Hello good day viewers, here is our last problem. In this tutorial we are going to integrate the function 1 divided by x multiplied by the square root of x squared minus x plus 1 with respect to x. Alright, first of all I would like to get rid of this x right here. I only want to see square root of a function down here. And how can we do that? By substitution. So let x be equal to 1 divided by, let me use t, such that this t is equal to 1 divided by x, right? So we are coming back for this. Let us differentiate both sides of this equation. We have dx equal to negative 1 divided by t squared. So now let us back substitute. From here you can see that 1 dx is the same thing as dx, right? And our dx is equal to negative 1 divided by t squared. Okay, we should have dt here. So we have the integral of negative 1 divided by t squared dt to the top. To the bottom, already we have declared x with 1 divided by t. So we have 1 divided by t for x, then multiply by the square root of x squared minus x plus 1. Square root of x squared, which is the same thing as 1 divided by t squared, minus x, that is minus 1 divided by t, then plus 1. Inside our square root right here, which is the radicand, I would like to factor out 1 divided by t squared. So this is equal to the integral of negative 1 divided by t squared dt divided by 1 divided by t multiplied by the square root of, I would like to factor out 1 divided by t squared. Then inside, from this term, we have 1 left, right? Take this, divide by what you have factored out, you have negative t. Then plus 1 divided by that, you have t squared. We are moving. Then if you take the square root of 1 divided by t squared, you are going to obtain 1 divided by t. As it comes out, it will multiply this. So you have 1 divided by t squared. So this is equal to the integral of negative 1 divided by t squared dt divided by 1 divided by t squared, right? Multiply by the square root of, I can rearrange it as t squared minus t plus 1. From here, this will cancel this. So to the top, we only have negative dt, and we can bring the negative sign outside. So this is equal to negative the integral of dt, right? Divided by the square root of t squared minus t plus 1. This is what we have. Now let us make these two terms a complete squared. So this is equal to negative the integral of dt divided by the square root of t squared minus t. Coefficient of t is negative 1 divided by 2. You have negative 1 divided by 2. Square that, you have 1 divided by 4. Alright, sorry, here we have plus, not minus. We have plus 1, but since we have added this to neutralize it, we are going to subtract it. Everything is now balanced. This is equal to negative the integral of dt divided by the square root of, these first 3 terms can be written as t minus 1 divided by 2 all squared. T minus 1 divided by 2 all squared. Then if you simplify this, you are going to obtain 3 over 4. So we have plus 3 divided by 4. I would like to do another substitution right here. So let t minus 1 divided by 2 be equal to the square root of 3 divided by 4. Why I want to take square root? Because power of 2 will eliminate the square root. Then multiply by tangent of what? Theta. Let us differentiate both sides. If you differentiate t, you have dt. You differentiate 1 divided by 2 negative, you have 0. So to the other side, this remains constant, which is square root of 3 divided by 4. secant squared theta, because if you differentiate tan theta, you're going to obtain secant squared theta. Then we have d theta. Let us back substitute. Already we have dt here, which we are going to replace with the whole of this. So this is equal to negative the integral of the whole of this, square root of 3 divided by 4 secant squared theta d theta, divided by the square root of what? We have the whole of this squared, which is this squared. So we have 3 over 4 times squared theta, 3 over 4 times squared theta. Then we have the last term, which is 3 divided by 4. 3 divided by 4. Now, since we have 3 divided by 4 here, let us factor it. So this is equal to negative the integral of square root of 3 divided by 4 secant squared theta d theta, divided by the square root of 3 divided by 4 outside. In the bracket, we have tan squared theta plus 1, right? Tan squared theta plus 1 is nothing but secant squared theta. So let us replace this one with secant squared theta. So we have this to be equal to the integral of the square root of 3 divided by 4 secant squared theta d theta. We divided by square root of 3 divided by 4 multiplied by secant squared theta, because I told you tan squared theta plus 1 is secant squared theta. Now let us take the square root of the denominator. We have this to be equal to negative the integral of square root of 3 divided by 4 secant squared theta d theta, divided by square root of 3 divided by 4 remain square root of 3 divided by 4. Square root of secant squared theta will give us secant theta. So for cancellation, you can clearly see that this will cancel this, and secant theta will go into secant squared theta one time. So we only have secant theta d theta as our main function. So this is equal to negative integral of secant theta d theta. So how can we integrate secant theta? It is the same thing as what? Natural log of secant theta plus tan theta. But remember, we have a negative sign. So this is equal to negative natural log of the absolute value of secant theta plus tangent theta plus the constant of integration. We are done. But remember that our main function was in terms of x, not in terms of theta. So we have to back substitute. All right, coming back here, t minus 1 divided by 2 is equal to the square root of 3 divided by 4 tan theta. I remember that t is 1 over x, right? From here, let me see. Yeah, you can see it. T is 1 over x. So let me just copy this one and replace t with 1 divided by x. So here is where we're going to solve for theta. I replace it back here to obtain our final solution. But remember that t is 1 divided by x, right? So we have 1 divided by x minus 1 divided by 2 equal to square root of 3 divided by 2, because square root of 3 remains square root of 3, but square root of 4 is 2. We have tangent theta. We can simplify the left hand side. We have 2 minus x, right, divided by 2x. And this is equal to square root of 3 divided by 2 tangent of theta. I can write square root of 3 divided by 2 as what? 3 divided by 2 root 3 for a reason. If we multiply the top and the bottom by root 3, this is what I mean. If you have square root of 3 divided by 2, multiply the top and the bottom by square root of 3. To the top, you have square root of 9, which is 3. So this will give us 3 divided by 2 root 3. I'm doing this for a reason. You will see that very soon. So this is what? 2 minus x divided by 2x equal to 3 divided by 2 root 3 tangent of theta. So let us make tangent of theta the subject by multiplying both sides by the reciprocal of this, which is going to give us what? 2 root 3 divided by 3. So it's like we are going to multiply this by 2 root 3 divided by 3. We also have to do it here. 2 root 3 divided by 3. You can clearly see that this will cancel this will cancel this, right? Tangent theta equal to what? If you multiply the top here, you have what? 2 root 3 multiplied by 2 minus x divided by 3 times 2x, you have what? 6x. Or you can say that 3 multiplied by 2x, because I want to cancel something here. You can see that 2 will cancel 2, right? Tangent theta is equal to root 3. If you like, you can expand. I can say 2 root 3 minus root 3x divided by 3x. We're almost done. To find theta, we are going to take tan inverse of both sides. So theta is equal to arctangent or tan inverse of the whole of this. 2 root 3 minus root 3x divided by 3x. So this is what we need to replace for theta in our main solution, which is this one. So let me just copy this one and substitute. All right, this is our final solution. Let us substitute theta. Wherever we have theta, we are going to replace it with the right hand side of this equation. So finally, we have this to be equal to negative natural log of the absolute value of secant theta, but theta is what? Tan inverse of 2 root 3. We have 2 root 3 minus root 3x divided by 3x, right? Then plus tangent, but because we have theta to be equal to tan inverse, this tan and this will cancel, leaving only the function. So we're only going to write 2 root 3 minus root 3x divided by 3x, right? The absolute value is here, then plus the constant of integration, and we are done. This is just the solution to that problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.